All right, guys, I'm Nicolette, and today Brian and I are here with Sam Sadri. He is a semiconductor packaging engineer over at Quik-Pak, and today we are going to talk about the evolution of chip technology. We're going to talk about engineers, future tech. We're going to talk about a lot of fun, trending stuff today. So thank you so much for joining us, Sam. We appreciate the time.
Thank you. Hi, everybody. Hope you're having a nice day. Please stay safe. And I'll go ahead and introduce myself. My name is Sam Sadri. I am a packaging engineer here at Quik-Pak, and my background is I've been in packaging basically since 1984. That's when I graduated from Arizona State University, go there, Sun Devils, with Bachelor of Science in Electrical Engineering. A couple of years later, I started, couple of months later, okay, not years. Okay, so in May, I graduated. In July, I started my first job as a marketing engineer for General Semiconductor. It's a Square D company. We did fabrication. We basically making power semiconductors, switching power, so for switching power supplies. I'm sure you have many at home. You have many of the products that similar companies like General Semiconductor made. It's for AC, DC, DC, AC converters, that type of product. After 4 years, I moved to Tucson. I worked for a substrate company, made aluminum nitride. Again, this is many years ago. Aluminum nitride was the coolest thing 30 years ago. Well, of course, not today. But then after that, I moved back to Phoenix. 4 years I was in Tucson. Moved that back to Phoenix, and I started my MBA program 2 years after I finished my MBA. Kyocera in San Diego hired me. Then that was 1995, and since then I've been in San Diego. I worked at Kyocera for 5 years, and then after that I moved to Meltronics, and now I'm at Quik-Pak. In a few months it will be 5 years since I've been at Quik-Pak, and I wanted to share my 30 plus years experience in packaging. Now, how do you do that in a podcast? Well, that's when I put together some, what I call the 10 commandment of packaging. And for this one, actually, I did not go to the mountain. It came to me. So, so I wanted to share that with all the folks here.
Yeah, go for it. Go for it.
Yeah. So here comes the first commandment, what I call reduce, eliminate handling. This is so important. That's why I put it as my first commandment. The less you handle parts, the better in our business, which we take a semiconductor and we package it, put it inside the package, wire bond, flip chip, different ways of, but the more you reduce handling, the better. How do people do this? We do what's called a universal tray, a tray that, for let's say it's a tray that's made out of a PEEK, for example, plastic. Polyethylene ether ketone is a material that's very inert, doesn't activate with solutions and things. So something like that, imagine, and then you have this basically this tray, but it has inserts that you can open or close, removing these inserts. So as your size gets smaller or larger, you can place these in different, by moving the inserts, you can accommodate. Another, this is funny, just reminded me, a couple of years ago, I was in DC and I came across, went to a museum, I came across pictures of folks, 1960s, at JPL NASA, building products, and these are transistors with like 3 transistor on a chip, which was state of the art at that time. Today, there's billions, millions of transistors on a chip. But I noticed on the tables, the ladies that were doing the actual wire bonding, they had trays just like the ones we use today. So I think this reduced handling has been it's been something that I think has been out there. And from 40, 50 years ago. Nowadays, what we do is, and that's through automation, there's what's called input-output trays. You bring all the parts inside these our trays and you put them at the machine input. And the machine goes, grabs the trays, brings it, puts it on a stage, does the wire bonding, comes out, and then goes into the output tray. So all the operator does loads and unloads it into these trays, and then they move it to the next operation. Same thing. Now automation is expensive. That's one thing you have to be aware of. So only makes sense when there's volume involved. But even for smaller quantity, having trays and not moving parts one at a time, just moving them inside these metal trays that are, also good for EST so you don't zap parts, but moving them, that's an example of reducing handling. I always, encourage our guys, to come up with ways as much as they can to reduce the handling, and this is by putting, for example, die attach and wire bond next to each other. So you don't have to move from one end of the factory to the other end, for the next process. So those are some of the things, that they do for that kind of, to reduce handling.
The less you could touch a part, the safer it's going to be, the less you're going to short it out, or do you know what I mean? Or even like, think about,
you touch it. That was my question.
Well, think about it. Like, even like when you assemble a computer, right? You don't want to touch the processor because you get your fingerprints on it. You get the oil from your hand on it. And then, when you have to bond the heatsink to it, there's so many things you don't want to touch.
Are you
right?
You're in some other life, Brian? Is that it? Are you an engineer in some other life?
I'm impressed.
She always forgets that I used to actually own a computer manufacturing company.
There you go. Brian has a very good point. Why is dead skin oil? Why is that bad? You ever think about it? Dead skin is organic. It's carbon, organic. And what happens to organic when it sees high temperature? It carbonizes. Okay. What happens to carbon? Have you ever tried with a pencil? If you take a pencil and scratch it on a piece of metal and send it to plating, that will actually plate because it's conductive. So again, organic carbonizes, carbon gets transfers electricity, create a short. That's why oil and these are not good in our business. Yes. Okay. If I may move to the next, which kind of follows actually the second commandment is how important cleanliness is to our business. Super critical. And this kind of made me think of the term, bug, where that, you heard software bug, the origin of that is actually, it was on a mainframe, again, many, many moons ago, that actually a bug, not a bug, but a caterpillar, before it becomes a cocoon, that went somehow into the mainframe, got zapped, and created a short. Therefore, the term bug comes, software bug. When they talk about, there's a bug in the software, that's where the origin came from. So
literally means a bug.
Yes, well, it did, so many years ago. So how important the cleanliness is to our business. Again, that's why we work on the laminate flows. That's why we work in a 10,000 class clean room. Right? So it's super critical that we keep everything every day. At work, what we do, the first thing we do is we clean everything, we wipe wipe everything. That's our first task of the day. I mean, don't look at my desk, but in the line is totally different, guys. Cleanliness is super critical to our business, just because of this carbonizing effect that happens to organics and things. So that's what, like I said, we work in flow hood. We work in a very clean room, clean room. We actually measure the cleanliness of our air. We have tools that measures. We look for 0.3 micron and 0.5 micron particles, and if we see more than a few, then that means there's something wrong. Then we have to stop and see where it's coming from, and fix all that. So so that is how important cleanliness is to our business. To the next command, and we're on the third now, which says if you see something, say something. Okay, and this is really has to do with the culture of the company and how you tell people, your operators, if they notice something, because they're the first line of defense. Okay, if you see something, if you notice something, raise it. Don't be afraid, because people, I mean, I'm including myself, we always, we're concerned about how fast the schedule, we don't want to, but those are important, but more important, what good is making something at the end that doesn't work?
Right.
It's important to raise it and not be afraid to raise it. So
yeah, I mean, Sam, that totally, it ups the quality of the product, right? If everyone's on the lookout for anything that may go wrong, it totally raises the quality.
Yes, yeah, and so one way to encourage people to do that is a program we call CIP, continuous improvement process. We basically we reward our operators if they come up with if they think of something, a way to do something different that will improve the quality. We actually reward them by again, it's not about the reward. It's about it's a small reward, but the fact that they bring it up and not be afraid of raising it. Okay, don't be afraid it's going to affect you or your speed of your process. That's the culture that I'm talking about, and I see that happening here. I've been again here for about 5 years, and I do see programs actually in this at Quik-Pak that rewards people when they raise issues.
That's great.
So that I encourage you to, the audience also to think about same process, or something in the parallel to the same process. Moving on to my fourth commandment is predicting failure. Okay, and it's not an easy thing, but try to predict failure. And perhaps I can make an example, a very, very common example. Let's say you go home tonight. Say, Brian, you go home tonight and you notice that, it's raining, which doesn't happen in San Diego often, but let's say it's raining and you notice there's like a drip, okay, from your ceiling. Okay, now you can put a pan under it and ignore it, and then 2 days later you come and it's still raining, and you see, oh, there's more. Not drip is like before it was 2 drips a minute. Now it's like 4 drips a minute. Okay, well, what does that tell you? That something is wrong with your roof. Now you can ignore it, and because I know roof is always expensive to fix, but you can ignore it and just placing larger pots under the drip, or you can go up and send somebody up there to check. And because when it's a small leak, much easier, a lot cheaper to fix than it just if it's ignored. Same applies. Same applies to our business. If you let's say we use mats for ESD, all our tables are mats. Have mats, and we measure the resistivity on these mats And if they get, you keep on, and eventually, you have to replace it. But you can predict that, having a trend that, you measure it every month, and then you see, oh, there's a trend every year, like 2 out of 40 goes bad. So now you know what the trend is. Now you can predict by don't letting it go bad. Just before that time, just remove them, put brand new all over the factory, every 2 years, so those are the kind of prediction that really helps our business before it gets bad. You can stop
and
it.
also, I mean, just the prediction that's going to be replaced, but the prediction of what you're going to need to purchase in the future, right? So the maintenance, so
there you
a
go.
lot of prediction.
There you go. So, so those are some very, simple examples, but then we can expand on it. If I may now move to the fifth commandment, which is environmental effects and mitigate the environmental effects. And I'll give you an example. We have in our procedures, we say that we watch our humidity. We have controls over humidity, and so if it's between 35% and 6, that's the range we can work. Right. Humidity between 35 and 65. Below 35, we stop. Production stops because why is that? Because of ESD, electrostatic discharge. And I'm sure we all have felt it walking on a carpet and touching the doorknob. You get zapped, right? And it's the same. Now that zap is a very high voltage, very low current. Wakes us up. When it zaps, but in an electronic, it will kill it. It will kill a semiconductor chip, because of its high voltage and low current. It will destroy. And I've been in the ESD program, and it is such a hard thing to pinpoint and find, do failure analysis. So I found it's best to just avoid it. Avoid it by not working. And what happens if things go below 35%? We stop and we bring humidifiers into the line. We put humidifiers.
So instead of even taking the chance, you're just totally avoiding.
Right. That is exactly predicting failure. Back to commandment number 4. So now, what about over 65%? Well, too much humidity causes corrosion. Bad things happen to our tools. Okay, so there's also a thing called dehumidifier, which takes the moisture from the air, lowers the moisture, and just dumps it into the into it's just water, right? So it gets rid of it. So that's important to have that range. So that is very important in our business. And what we do, we package semiconductors. So just imagine all the time and money spent to fabricate, and now at the very end, just because you touched it. And and there's a lot of mitigation on ESC. That was just one example. We also ground ourselves with ground straps. We have a conductive floor, or we have ESD shoes. We have I can go on and go on all the things we do to avoid. And it's a lot of it's a lot of money. Believe me, we invest a lot of money in to avoid ESC in the first place. And that's what I find is best to just not have it, rather than something happen and try to figure what happened, where it happened, and how it happened. So that's environmental effect. That's really important to our business. If I may move to the sixth commandment, is the verify. I say verify your own work. Always, when you build something, I give you an example. Let's say you're doing die attach, which is followed by wire bonding, for example. Now, verify that the die attach is done right, because if it's not done right, the next guy is going to have a problem trying to wire bond because it's not sitting flat. There's a little bit of skew. So I encourage people, our operators, to always, verify their own work. And also, that's my next commandment, 7, also verify each other's work. Okay. And don't take
So
it
6 and 7
personal.
sort of go hand in hand, right? It's
Right,
your
there you
artwork,
go.
but
Signaling.
yeah.
Don't and again, go back to the culture. It's important that if somebody sees something and raises it, don't take it personally, you know, but instead congratulate your fellow worker
Right.
and thank him for raising it and bringing it to your attention, because you know, we all, at the end, we all work together. You know, it's one company. So it's important that you know, that we're open. You know, we share with each other issues, and we check each other's work. There's a cross training, cross training, and you know,
Yeah.
and through all the training and cross training, this is how you mitigate these issues coming from, you know, processes that people do. Because still, you know, although we have a lot of automation, there's still a lot of handwork going on
Right.
in our business.
Right.
Okay.
And, you know, if one time you're, you know, if you're someone sees something you do, you're going to see something they do another time. So people should definitely not take it personally. It's
No,
everyone
no,
can do
no.
the same thing. Yeah.
Yeah, and again, back to the culture, and I had trouble with that, you know, when I first started. But I think a repetition, when you keep on repeating something over and over and over again, eventually it sits on people's heart, especially when it comes from the bottom of your heart, and they see there's no precaution, there's nothing bad will happen if they catch something. Actually, we reward them if they catch something.
Right.
So that's my that's how it's 6 and 7, you know, verifying your own work and checking each other's work, I think is very important. If I move now to the 8th, the 8th commandment is devil is in the details. And it sure is. You know, sometimes, you know, you get this drawings, there's you know, 20 pages of it, so many notes here and there, and there's a small note, let's say, that talks about parallelism of two surfaces, and somehow you ignore that, or not ignore, but you miss it. And then that's what, and then finally customer tries to put it in their socket, and the thing, you know, that comes from the top is not parallel with the bottom, and they can't test. So a small detail in a drawing that was missed can create so much issues for. So so I always encourage my technicians, the operators, pay attention to details, even small details, because those are usually what you know, what they get you. Now we also have quality control, you know, which is separate. You know, the quality and production, typically you need to separate the two groups, because you know, quality, I hate to say this, policeman, because I don't like saying that, because in my mind, quality must be designed in and not inspected and inspected and inspected. So so you, once you design the quality into your product, it should be okay, you know. And I don't like calling QA policeman, but that's just sometimes that's what people think about when it comes to quality. So so it's important that you know, quality is also involved in all processes, checking checking people's work. This morning I was in the line and I saw my tech was doing a flip chip, and but before she placed it, she went and got a QC inspector to verify that it's the right orientation. You know, something as simple as that. And you know, 99 out of 100, it's all correct. But even that one time, if you know, this catches even one problem, it's worth it. It's worth it. It's worth the trouble. Okay, so that's pay attention to details, always. Now moving to my 9th commandment, which is the one that maybe I should have put it at the first, and I tell you why. But the commandment is that don't overlook final packaging and shipping. Okay, why is that important? Imagine when I'm finally done with something, there's many hours spent to fabricate it, to package it. And imagine if we put it in the wrong tray, and during transport it comes out and gets banged everywhere, and finally customer gets it, and they can't test it because everything is bended. Okay, so what is at the very end of the process, which is correct packaging.
Mhm.
It is so critical in our business that it's done right. And once you give your product, you're done with it, and you give it to shipping or somebody to package it, watch that, make sure it's done right. I mean, FedEx, UPS,
Right.
they're great, but sometimes I've seen they drop. It's possible to drop a box, so it's important to protect it. Protect it and protect it well. And then, this is again a story I wanted to bring up. Why is important, even how we invoice and how we packing slip, all these things. Years ago, we built product transistors for aerospace company. This was for space, so you can imagine. And when things go to space, there's no Radio Shack up there, right?
No.
So you have to make sure your quality is the best, and there's always two systems backing each other up. There's RAND, so that's how, so we built this product and took us weeks to build it, and we were so excited that finally we did 100, and this transistor gold plated, looked pretty, and so excited. And we took hand carried actually to the customer, which was about 100 miles away, and everybody was so thankful. And but guess what, at the end of the day, we did not get paid for that work, and it was a big ticketed item. 24,000, guys, 30 years ago was a lot of money. Okay. So, but we did not get paid. Why? Because it did not go through their shipping and receiving. So excited, we gave it directly to the engineer, and it did not go through their system. So, making a long story short, and maybe they wanted to make an example out of us, rightfully so. We were not paid for all the work because we did not follow the right track. So this is at the very end. So, it's not important. But guess what? And I know this doesn't happen often, but it's important enough to pay attention. Believe me, I'll never take anything directly to customer without going to their shipping and receiving. That's my lesson. So I hope the audience also, for the same thing. And finally, going to the last commandment is that learn from the past. I just brought up something that happened in my past some 20, 30 years ago. Learn from your successes, and also learn from your failures. I say failure is okay as long as you don't have too many of them and you learn from it and not repeat it. Imagine I do the same thing again and take parts to a customer directly, and then I haven't learned from my failure.
Then
so
it's
try
time
to
fire you. If we're out another 24,000, I think it's time to go, right?
I don't know. I think that NASA engineer pocketed that gold-plated transistor.
This for one thing, this wasn't a Quik-Pak. This was a long time ago, and we all learn from it. But
he's like, no pack and slip, it's free.
I thought that was very sweet when you said you hand delivered it. I thought, wow,
yeah.
That's
I thought it was going to go down this route. We were hand delivering it. We knocked on this door. The guy tripped over the saddle coming in, destroyed the part, and that was it.
I wish. So just because it's the last of the process, just because packaging is the last thing you do, just because delivering is the last thing you do, doesn't mean it's not important. It is most important, actually. That is, this is all done right. So
it's funny. You were talking about shipping, and I just saw this article on, it was a bicycle manufacturer, and what they started doing is when they ship their bikes, they actually use a box that looks like it's a television box that says Fragile on it, but a picture of the bike is in the television. So the people delivering it think they're delivering TV, so they're extra cautious. Wait, and they reduce damaged returns by 80% on their bicycles.
Are you serious? Oh, wow.
Yeah. How crazy is that? Just because now whoever's delivering it, whatever company, I guess they're more cautious with it because it's a TV versus a bicycle.
Yeah, no, I
So
get it.
it's
You know, I
interesting.
mean, we do have stickers as fragiles and things, you know, that we put on products that, and you know, it's human nature. You know, I've seen sometimes these guys FedEx. I've seen them carry like 10 boxes,
Mhm.
you know, and one can drop. So
Yeah,
it's
absolutely.
whatever you have in there, you need to protect it. You have to protect it.
Absolutely.
You know, believe it or not, Brian, actually, we actually drop ourselves. I've done
Mhm.
this myself. You know, package something,
Yeah, to
drop
test
it a
it.
few times, open it and look inside, see if it's
Yeah.
working. That's how I qualify our packaging trays
Mhm.
and things. You
Yeah.
know, real life. Yeah.
Absolutely.
So, so those are those are the 10 commandment. As you know, as I've gone, you know, I've developed for the past 30 plus years. You know, I look at yeah, I don't know the Brian Hall, but I was born 1961.
Uh-huh.
Okay, and 1969 is, you know, when man landed on the moon.
Mhm.
So I was 8 years old, but I still remember what I had for lunch that day.
Wow.
Believe it or not, you know. So that's the if that's the stamp that it left for
Mhm.
me in my brain.
Is that what
And
got you into engineering?
is how I got into
Is that
engineering.
no, is that what
No,
got you into engineering?
no, I don't. You know, I was just strong in math
Uh-huh.
always. You know, and that seems to be. And I took biology. My
Uh-huh.
first term, I wanted to be a doctor. You know, but I could not handle all the names and things. So, but math came so natural to me, and that's probably where it put me into engineering, because I was good at math. But you know, so I remember. So imagine 1969 when man landed on the moon. You know, Neil Armstrong, Edwin Aldrin, and Buzz Aldrin.
Uh-huh.
Buzz Aldrin. You know, the gentlemen that landed on the moon, and the technology. You know, I was reading that. You know, the computer, the guidance system
Mhm.
that they used to land on the moon and those are the computers you have to actually manually program them.
Right.
You know, ones and zero, like PDP 11.
Right.
You know, years ago I used to, you know, program. Um, and I look at but and they landed on the moon. You know,
Mhm.
and today an iPhone. You know, if you have, I'm a Samsung
Yeah.
guy myself, but iPhone is 100,000 times stronger than
Mhm.
and the computer that they used, you know, to land on the moon. So look at the technology where we were and where
Yeah.
we are today.
Well, even the size of components, which is crazy. So here's my question. In your 30 years, what do you think what have you seen the most advance in size, like the size of components? I know we you know,
Mm.
we increased the capacity of like computers and things like that.
Right. You know, I see that as you know, miniaturization. You know how
Mhm.
we, if you're ever in DC, you know, there's a museum there for science, and go see. You know, they have pictures of what they used to, what a chip looked. You know, three transistors, and that was
Right.
state of the art, and how they did it.
Mhm.
And what today they put millions and billions on a transistor on the same footprint. So how we have reduced the
Right.
footprint, miniaturization.
Mhm.
You know, obviously cell phone is a big thing. I mean, all the things you see on cell phone today's
Mhm.
is a technology that was, you know, laptop computers.
Right.
Seems to me like every 10, 15 years there's something, you know,
Mhm.
it's either a, you know, computer or a telephone or you know, and what it was and what it is today. You know, just how much information, how much more information
Mhm.
we can do. You know, when I started, because it's a good point, Brian, when I started my first job, there were no computers, okay,
Mhm.
and I remember we had three ladies up front typing codes all day. Nobody had a computer. It took, you know, we had a telex machine, no fax, no FedEx. You know, I think FedEx was out. You know, FedEx was in business, but no fax. We just had a telex machine because we dealt with Europe, but
Mhm.
everything else was paper. Just paper, paper,
Wow.
paper. And how efficient what we were, you know, 30, 40 years ago and what we are today as far as efficiency, blows my mind. Okay.
Mm-hmm.
And this is all through the, technologies, through the information. I mean, 5G, for example, just imagine the bandwidth on a 5G versus even 4G. I mean, today 4G is right around, I think, 2000 megahertz. That's now 5G. We're talking 28 gig, 28 gigahertz. Peak. I mean, that's the peak. But even today between 4G and 5G, look at, I can't even imagine the bandwidth. Last night, Brian, I was counting. I had 11. In our home, there's 11 iPads, iPhones, Bluetooth devices. Just imagine these things all working, connectivity. I mean, that blows my mind.
And then on top of it, you have like now all your appliances that are connected. It's not even like your devices; it's your appliances that get connected. So I have a question. The
Yes,
technology, the technology has been there for some time. Do you think it's really the speeds, like 5G catching up to how fast the technology could process? You see what I'm saying, and all that data? Or do you think like it's almost like a chicken and egg question, right? Is technology going to get more advanced, or do we need to increase the speeds to get the to get that information where it needs to go, or that data where it needs to go, especially as things become more and more real time, and especially with AI and things syncing cloud? What do you think? Do you think the technology is going to keep pushing the pace, or is it eventually like the speed's going to be ahead of the technology?
Well, I mean, planet Earth is planet Earth, right? And right now with 5G, once it's implemented, we can certainly connect. Connectivity becomes so much easier. But when you get to, 28 5G, that's almost like millimeter wave. That is millimeter wave. These, unless you're talking stars talking to each other, or you're outside, that's when you get to terahertz and millimeter wave. But our planet Earth is all about connectivity, more devices. One family having 11 devices that connects to each other. We also another these are Brian, we make products for space, for military, but the one that excites me the most is medical. When we make products for medical, and when I see a glucose, for example, a glucose monitor, that you put this sensor basically in your wrist, and then your watch tells you your glucose level. You can program it every 10 seconds, every 2 minutes, and then that watch talks to the pump that gives you the insulin. Can you imagine a diabetes person not worry about poking and thinking about, and that's what excites me when it comes to technology. A person sitting here with no medicine, no doctor, and 100 miles away, but with this technology, they can troubleshoot what's wrong with you. And when there's these are the kind of things that excites me. Yet cell phones are going to be more and more. This is not a phone. This is a computer. Okay. And it's going to get smaller. It's going to get faster, all that. But there comes a time that, speed, there's so many transistors, okay, in the 6 nanometer, there's so much you can put on a chip. Now it's a system on a chip. There's no longer just one device, but they put a whole system into one chip. So it's going to get smaller. Things are going to be smaller. Things are going to be much faster.
So
and
you bring up an interesting point, right? And I was explaining this to my daughter a little bit earlier. We were talking about like AirDropping, like from Apple device to Apple device versus she's like, why does it take so long when you have to approve? I want to download, she downloads apps and I have to approve it. And I'm like explaining to her, like, okay, when you submit it, it goes all the way out to some server somewhere, and it pings back and forth and it has all these hops. Versus when you're airdropping something, you're directly connecting to my device, right? We're connecting to each other. Do you think we're going to see as more and more data, like you mentioned, like checking like your blood, your watch and your wrist, right? Do you think we're going to see a lot more in medical, a lot more devices talking to each other, near?
Oh,
Versus
you bet. Oh, you
out
bet.
to the
You bet. It's
cloud?
just, the problem with medical is, is how long it takes to qualify,
Right.
all the FDA, with cell phone, you have a proven technology, but with medical, you have to test people. There's different phases, that's why it takes a long time. But I think that's going to be next, all the advances in, medical technology and how people, how just diagnostic becomes so much quicker, so much faster. And it's all, by the way, this thing I was telling you, it's all on your cell phone. The pump, all the connectivity is through your cell phone. Your glucose, the monitor is in your wrist, talking to the watch, and watch talking to the pump. But this is what drives all of it, because you have to have a brain to handle all that.
Absolutely.
So I think this is gonna be the origin of where we are going. Yes, it will continue get smaller, get thinner. Flex. There's flex. There's all kinds of technology. That this is gonna get faster. 5G. But I think it's about connectivity of all these devices together. I think it's about there's so fast you can download and upload all that. And but there'll be a time that this is going to be, because this is in the air. Okay. It's not a fiber optic, or everything happens is in the air. And the air has the best dielectric. That's why point to point works. So it'll be interesting. I see some of it, because we make prototypes, we make small quantities of cool stuff. But what I see, what's happening out there is all about, speed is important, but it's bandwidth.
Right.
It's how many channels you put on a, you can have multiple channels, you can have one channel, but bandwidth is important. Connectivity is more important, I think, than speed. I mean, speed, of course, but it's what you do with that speed that counts.
Yeah.
So, Sam, I want to ask you a question, because this has been an incredibly educational time with you. But I want to talk about the engineer. I want to really wrap up with something for the engineer in terms of looking into the future and what the engineer should be thinking about now, as we talk about all these things to expect. What should they be thinking about as they design? What can you leave them with today?
Well, oh, okay. I play with my phone. Can you hear me? I want to make sure.
Yeah, I hear you.
Okay, because I stopped hearing you. I'm sorry. Would you repeat that one more time?
Sure. So after we're looking into the future, and you and Brian were talking about some things that, we may expect, right? And we can definitely expect. But what do you think the design engineer needs to be thinking about as they go forward? What can you leave them with today, to prepare them, or just give them some food for thought?
Okay. Well, the first thought is, please look at those 10 commandments. Remember them, because this is important. Every single one of them is important, and it's important that you guys think about this also at the design stage. I think, like I said, quality is the policeman, but I think quality must be designed in. So think about when you're designing something, think about environmental effects. What this thing is temperature wise is going to see, and always guard banded. The guard band, because it may fail here, but make sure your design is good up to here. So put as much guard band as you can. I'm trying to pursue my own daughter to go to engineering, and I know this is not, it's not easy, but I think. It's, math is important, definitely. But as you, this is the future. What we do as design engineers, especially in medical, purposes, for medical, or even military, because the balance of power, these are important. I know when I was building power transistors, I never thought of, well, this is, my thoughts were that, oh, this is going to go into an F-16, and and it's a bird of prey. I mean, it's a fighter. But this balance of power is important. That's what keeps us, to have this balance. So it's important, although, aerospace, all that, medical, but as design engineers, think about connectivity, think about bandwidth, and again, look at these 10 commandments. I'm sure, use it in your design. When you think about these things, because eventually that design is going to be out there, and it's going to see the temperatures, it's going to see, it's going to see all kinds of things that, and one thing also good is that we have standards, just like any industry. We have standards, and it's 883, that's one for microcircuits, but there's standards for everything. And knowing those standards, I know 883 has so many pages, but in your free time, read them, because this was put together by a panel of engineers. Every page, many hours was spent to develop these criterias. So although let's say you are a design engineer, you're designing a chip, but understand your next process of packaging, see how they do it, and have a full understanding of the whole process, not just what you do, but the whole process. So those are, I mean, V equal IR. I mean, I'm not going to get into little formulas or Ohm's law. They design engineers know all that. It's about the details. It's about the little small details that's important, and know as much as you can about the next process. That would be my recommendation.
That sounds good, Sam. Thank you for that.
Yeah.
Well, this has been incredibly educational, and for the audience out there, we're going to get those commandments typed up and whatnot so that you have. But in the meantime, Sam, can you let everybody know where they can learn more about you and Quik-Pak?
Oh, our website, which is going through a redesign, www.icproto.com. That's I as India, C as Charlie, Proto, PROTO.com. It's getting redesigned. I am not part of sales, but I'm sure if you want to talk to me, I don't know if I can put my information out there, Nicole, but we just lost Nicole.
Yeah, no.
Okay.
If you want people can email you directly if you want to share your email.
Oh, I don't mind doing that. Is that okay, Rosie?
Yeah.
I mean,
yeah,
Rosie.
Put everything in the notes.
Yeah, we can put it. We'll put it in the description. So
yes, by all means,
Oh, there we go.
Is it backwards? I don't know.
Oh no, it's good. You're good. There you go, everyone. There's his email. You got a question?
all day.
Sam directly.
God help me. But no, I mean, one thing, guys, you may not know is my background. I've been both in process and the sales side. Half of my life I've been in sales and marketing, the other half in process. I have two rules of customer service. Okay. Rule number one, customer is always right. Rule number two, customer is wrong. See rule number one.
There you go.
So that is my mental. Of course, I add a little bit. Maybe that's another podcast. But I added. When they're wrong, lead them toward the right direction. That is my job. That's what I do.